wait a second. Okay, so officially welcome everyone to another meeting of the Seattle ASCE Environmental and Water Resources Institute. Today we're going to have a presentation by Mark Schroeder, who is an associate engineer at Integral Consulting, and Mark is broadly trained in environmental engineering and has focused experience in the fate and transport of contaminants in groundwater, soil, and sediment. Mark is an actively participating member of the ITRC, the Interstate Technology and Regulatory Council, in the tire anti-degradants, the 6PPD team, and he is assisting in the preparation of guidance materials with a wide range of experts on the subject. Mark has been with Integral since 2018, after completing his master's in environmental engineering from the University of Colorado Boulder and his bachelor's in environmental engineering again from Oregon State University. And today, Mark is going to give us a presentation about the 6PPD-quinone and things that we need to know about the contaminant. And just as a reminder, please mute your microphone. And when we have questions towards the end and in the middle today, feel free to turn your camera on when you're speaking. And if you have questions in between, please write them in the chat box. And with all that, Mark, I surrender the floor to you.
Great, thank you. Let's see, screen share. Oh.
Excellent.
Okay, yeah, thanks for inviting me, Dimitri. So yeah, I'm Mark Schroeder and at Integral Consulting, and this is a close to home topic for me. I actually just took this picture of a I think it's a Chinook salmon. They're starting to migrate up the creeks in Bellingham, Washington, where I live, just right now. So this is just a couple days ago. Yeah, Dimitri already kind of touched on it, but yeah, I'm an environmental engineer at Integral and did my master's at University of Colorado, also with a focus on fate and transport and water chemistry. But yeah, a lot of my background and experience in the workforce has been with a variety of related topics, site investigations and remediation, kind of throughout everything to do with chemistry, and a big part of that for me is like coded data analysis, like taking something complicated and repetitive and turning it into something that can be automated. And I think like a lot of people in this world, the outdoors has always been a big part of my life. So I'm very familiar with like mountaineering and the North Cascades and a lot of the kind of the ecosystems involved, and seeing the salmon has been kind of a nice way to tie it all together. I am actively involved with ITRC, which is the Interstate Technology and Regulatory Council, in their tire anti-degradant subgroup. ITRC is a pretty big organization that publishes guidance documents on a whole variety of topics related to the environment. They got a lot of traction with PFAS recently and have also published a whole bunch of so many different web-based guidances, kind of targeting regulators and people who make policy around these topics. So yeah, I have contributed to some of their documents and we're actively working on these right now. We have a focus sheet that just became available. It's as of last week, it's a 15-page kind of summary of 6PPD-quinone and kind of what the state of the knowledge is on kind of what I'll be presenting in this PowerPoint. That's basically how I've gotten a lot of my understanding of this chemical and what people are doing. Next summer, they're planning to publish the full web-based guidance document, and that's going to tackle those topics, like of the toxicity, where the research is going and the gaps, and then the solutions. And it's a whole variety of people, and they're always encouraging people to sign up and help. So if you are interested, they would be happy to have you, I think. And yeah, it's everybody from kind of private consultants to the U.S. Tire Manufacturers Association, to researchers and policymakers. So in this presentation, I'll go through these topics of background and kind of the history of how it was discovered, how toxic it is, how it moves through the environment, and how that fate and transport guides some of the solutions that we can mitigate how it enters waterways or find alternatives to the chemical. And then I'll touch on kind of what the current regulations and policy, where that's going in the future. A lot of this is kind of up in the air. The research and kind of the knowledge is really coming out in the past year and a half or so. So there's lots of new things happening all the time. So I tried to do my best to include all the sources I possibly could. And if you have any questions or want to read more, I have all the links to these sources listed in the end of the PowerPoint, scattered throughout. And then Dimitri mentioned, I'm happy to take some questions in the middle of the PowerPoint, maybe kind of at a halfway mark if people think of any. Otherwise, we talk about it more at the end. Okay, so this problem was observed in the previous couple decades. People were observing coho salmon to basically die before they could spawn as they moved upriver. So researchers and engineers have basically been seeing that it's from stormwater, but really up until recently, they didn't know what was causing this acute mortality. A lot of stormwater infrastructure right now is designed for flood control, and it hasn't been until semi-recently that it's been designed to filter out contaminants. So that's something that is going to be widely addressed in future policy-making decisions. But in 2020, it was discovered to be as 6PPD-quinone as the responsible contaminant by Tian et al. And I think throughout the presentation, you'll see a handful of names as people who have contributed a lot to the current research and who are actively sharing all of their work. So he's one, Tian et al. Are one of them. Let's start with the left kind of figure. They isolate, so there was kind of an understanding from 2015 to 2020 that it was coming from tire wear particles. So you'll see TWP, that's tire wear particles. So they started by taking kind of a synthetic mixture of tire wear particles, and they could isolate by chemical class and kind of just increasingly get narrower and narrower until they iterated through and found that it was 6PPD-quinone, which was responsible for the acute mortality seen in these juvenile coho on the right side of the screen. 6PPD itself is not particularly toxic, so that's what the parent compound is. Even when you take it and add 20 times the concentration to the water, the juvenile coho are still doing okay. But then when you add the degradant product, 6PPD-quinone, you start to see the fish exhibit the mortality or the acute mortality kind of syndrome of being kind of dazed and confused, gasping for air, starting to go belly up. And then when you see 6PPD-Q alone, that is when they die. It's acutely toxic to coho, and that's where we see it the most at like the lowest concentrations. But several other species of fish are also sensitive to it, like the white spotted char and the brook trout. those are highlighted because those are concentrations, and rainbow trout, those are concentrations that are measured in the environment. Chinook salmon were also found to be sensitive to 6-PPD-quinone, but at higher concentrations that are generally measured in stormwater. So kind of as far as the toxicity goes to them, it's less of a concern. There was a hypothesis that chum salmon, which are closely related to coho, might also be acutely affected by 6-PPD-quinone, but it seems like it was not. So right now, the research is going in towards studying how the chemical is affecting the brains of the fish, because that's what's causing them to kind of swim in that confused, almost drunken state. So right now, I know there's one of my coworkers is actually in the research group, and some of them are looking at how in the same research group as Tian et al. And working with Jen McIntyre, who's one of the leading researchers of the topic, and they're looking at how the contaminant crosses the blood-brain barrier and how that might affect coho salmon the most. One theory is that coho salmon have to make a longer trip upriver than some of the other species. So when it's at the end of their effective lifespan, they're more sensitive to different stressors in the environment, and 6-PPD-quinone is more acutely toxic. So that's kind of one theory of why it's affecting them the most. So what is 6-PPD, and why do we still have it? Basically, it's a critical ingredient to tire rubber. Without it, tires rapidly oxidize with the ozone in the air, and it really is a crucial part in how tires have the grip that they do when we drive, and basically it's used to meet safety standards. One interesting thing about 6-PPD is that it has this blooming effect where when it's mixed in with the car tires, it kind of resurfaces to the exterior and then can react in place of the rubber. So that's its effect. It's a very active compound in tires. Off the top of my head, I think it's about 1% of tires. There's a lot of knowledge gaps, as I alluded to. We know that it's acutely toxic to coho, but beyond the acute mortality of the salmon, how is it affecting them to other stressors? With climate change and warmer waters, is that also, like, are they going to be more sensitive to less oxygen in the creeks that they're migrating up to? Are there going to be other like parasites that can be more damaging to the salmon? So there's a whole bunch of things that we don't really know about, and we're studying. The other thing is we don't know how toxic it is to humans, because as of last year, it was measured in human urine. They collected samples from 150 people in those three categories: adult, children, and pregnant women, and they did find it in all of the populations where pregnant women had the highest concentrations. So beyond seeing that it's in people, we don't know how toxic it is, or if it's kind of crossing the blood-brain barrier, and who that might be most sensitive to. This picture on the right of Seattle is kind of just a good demonstration of how we have cars driving right over rivers, and it's just a huge non-point source contaminant that's kind of just now everywhere in our environment. And basically, it's going to be a really big challenge to figure out how to mitigate its migration into the waters. I also want to just kind of add that this is primarily on like highways where there's lots of traffic, basically, and since we don't know how it's affecting humans, we're not sure how air pollution and the tire wear particles as air particulates are being inhaled by people. And also the tribal nations in the Pacific Northwest are very deeply entwined with salmon as just a part of their culture. So as salmon populations decrease throughout the Northwest, there are treaty rights that grant them access to salmon just used as food does get smaller every year as the populations decrease. And recently, there are several lawsuits that are, I think, either filed or starting that are suing tire manufacturers to find alternative chemicals and replace them. They've also petitioned the EPA to regulate 6-PPD under the Toxic Substances Control Act. If you do want more information, I have a whole bunch of links for the little numbers are. And similarly, it's gained a lot of national attention all the way up to the New York Times, down through kind of like your local news. So I'm just leaving a bunch of links here in case you want to share this with other people who are interested for something that's very readable and easy to digest. So now I want to kind of transition over to the fate and transport side of the chemical. This is a little bit more of where I specialize in. I'm by no means an expert in the toxicology side of things. But right now I think we all have the understanding that it's coming from tire wear particles. So this conceptual model basically just kind of illustrates where all of these tire wear particles can move through the environment. Right now, there's most of the focus of research is under the kind of the aquatic environment of how it's affecting the coho salmon. But yeah, like I've mentioned, there's all these unknowns about, is it an inhalation issue? Are people ingesting it through the salmon they eat or catch? And yeah, where would those airborne particulates migrate to? The particle sizes range from 5 to 300 microns. So they can be very small all the way up to what you just see on the side of the highway. Basically, the smaller they are, though, the more kind of surface area allows it to leach 6-PPD-quinone, though. So it's the really small particles that we're most concerned about. I'm just leaving these kind of chemical parameters here because I think these are important for how we design treatment strategies. They're pretty similar for 6-PPD and the quinone. The solubility is high enough to where you see it be acutely affecting salmon. But the two coefficients of KOW and KOC, these are important for how the chemicals partition to soils and organic matter. So KOW is the coefficient for how the chemical partitions between water and octanol, so like a oil, and is a good description, kind of describes how it can bioaccumulate in fish. And KOC is how it partitions kind of to organic carbon in soils. So the number, like a value of 4 to 5 is on the higher end. So we know it has an affinity for soil and organic matter. And then the half-lives, these are fairly short as far as these contaminants go. So they are theoretical, though. So like that's something that's actively being studied right now, is how long they truly exist. These are theoretical values that come from some thermodynamic models. But yeah, in the end, we're going to have to design BMPs and long-term solutions that kind of follow how it partitions. A lot of the researchers have noted in their methodology that glass containers are required just because it's sorting to the plastic a lot to where it's affecting all of their experiments. So that'll also be something to consider as we start to sample it more, just on a more widespread basis. Let's see. Okay, so then this is where we're seeing 6-PPD and 6-PPD-quinone. It's really in the most urban environments. So like this figure on the left shows where there's the most urbanization and where samples for 6-PPD have been taken and found at the highest concentrations. So Seattle is definitely like a big priority. Roadway runoff is basically what's coming off of the road before it enters the urban streams. The acute mortality for coho, if you remember from the beginning, was 0.8 micrograms per liter. So if we're seeing it at over 2, then that is kind of the range we're working with. We're seeing it in both the runoff and in surface waters, kind of up into that level. And it's also being found in sediments and in the air at higher concentrations. There's also a lot of the other municipalities are observing it in different sources beyond just roadways, and that's something we also need to consider, like turf fields where they're using tire crumb rubber, landfills, really anywhere that tires can kind of end up in their life cycle. Oh, and then I think I would also like just add that these concentrations are highest generally during the first storms of the year. So that's when they're measuring these, because over the summers, all the tire wear particles are accumulating and accumulating. And then during the first kind of period through, yeah, I guess fall and into winter, those storms are starting to finally washing those out. And that's when you see the highest pulse of the contaminant load. So I think at this point, before we jump into kind of some of the BMPs or solutions, does anybody have any just quick questions or comments?
Mark, there has been one question from Caitlin. Sure. Are there any BMPs for remediation or mitigation being tested or used at this point? Maybe bioremediation?
Yep, there are a couple, and yeah, I'm gonna talk about that in this next section right here. So I think, yeah, we'll get right into it.
Anybody else have a question for Mark? I have a quick question, Mark, as well. Yeah. Are we aware if there is a replacement compound readily available that could replace it? I'm sure there are trade secrets here, but at least in the public, in the public domain, are we aware of any?
You could use right now. They are working on that. They are actively working on that. I think the most obvious replacement are other PPD compounds that are just not 6-PPD. The problem then is just whether those compounds are also toxic, and that's what they're studying right now and trying to figure out. And I have a slide at the very end of kind of where that's going. But yeah, that's a good question. Yeah, it's in progress.
I'm sure. Yeah, this is a new problem that has surfaced. I don't see any other questions. So please go ahead and continue.
Okay. Okay, so these are generally the identified solutions that I am seeing people talk about the most in ITRC, which is, I think we're seeing a large spectrum of all of the researchers through the US Tire Manufacturing Association come up with ideas. I've broken it down into near-term and long-term solutions. I think a lot of the focus on research right now is on the near term of just how do we minimize its effects. But yeah, then and that includes a lot of these BMPs and how do we treat water to remove it before it enters the streams. The long-term kind kind of solutions, are alternative chemicals for the tires, just finding something that can be replaced. But it's also roadway infrastructure. How do we design highways that can wear highways or roads that wear tires differently? How do we account for vehicles that are more heavy, as there's just more and more electric vehicles on the roads that have more or have heavy batteries and weigh more, because that affects how fast tires wear. Maybe it's futile, but driver behavior and how people speed or go around corners, because that affects tire wear. And then kind of finally, there's like the consideration of point source remediation. Like, do we need to remediate like at where the chemical is being produced in those industries? Right now, that's a little bit on the lower priority, just because we're seeing it as a non-point source at the moment. But something we're considering. Okay, so the Washington Department of Ecology has put out a really great document that goes through a whole variety of treatments for 6-PPD. A lot of the document is based off of kind of the theoretical understanding of how the contaminant moves through the environment and its chemistry and affinity for partitioning to organic matter. So the main takeaway from this document is they've classified BMPs into kind of a high, medium, and low effectiveness, where the highest, most effective BMPs are dispersion, infiltration, and biofiltration. Basically, how do we slow down water before it can get into the urban streams, and slowing down, but then also allowing the stormwater to kind of be filtered or infiltrated through, like bioswales, or kind of by plant uptake and different medias we can put into retention basins. So I think this really becomes, an engineering challenge of collecting the water, but then also designing the appropriate amount of different types of soils that can collect and filter the 6-PPD and 6-PPD-Q out of the water. And I will go into a few case studies. And I'll go into a few case studies next. But yeah, basically bioretention has shown to be effective, especially with different types of organic matter. People are actually just using compost and seeing pretty high removal rates. Right now, there has not been very much like published research on how effective treatment strategies are. I think that a lot of that is in the works, and it's being funded by the Washington Stormwater, Stormwater Action. I'm forgetting what the acronym is, but the state of Washington is funding a lot of research to look at the treatment effectiveness. A lot of stormwater treatment strategies also, they already slow down or filter runoff. So maybe these can be modified to specifically treat 6-PPD-Q, especially because stormwater has a wide range of different chemicals in it. They're all reacting with each other, and there's just so many that it's maybe most practical to actually just try to treat for all of them at once. This is a case study actually done in 2015 by Dr. Jen McIntyre, who helped lead the discovery of 6-PPD-quinone. So they were aware that it was coming from stormwater and kind of tire rubber at this time. So they collected different samples of stormwater, and experiment it, and on the same day they collected stormwater, they would experiment it. But they had these two sets of columns with and without bioretention soils to filter the stormwater before adding to those kind of tanks that the juvenile coho were in to test its effectiveness. And they did find that it removed quite a bit of the stormwater contaminants, even though they didn't realize it was 6-PPD-Q at the time. I think this kind of just supports the previous slide, as maybe we can kind of modify existing BMPs that treat stormwater to also just be effective for 6-PPD-Q. There's one other case study that people are aware of, and this is Ohop Creek. This was a kind of a case study pilot done last year. Ohop Creek is kind of just right in between Mount Rainier and Tacoma, just south of Seattle. And the Nisqually Indian tribe partnered with a handful of other consultants and people from the city to pilot biofiltration system, which is basically as simple as filling a dumpster with compost and then collecting the stormwater and allowing it to filter through. They found it did remove a lot of contaminants, including 6-PPD, to pretty high amounts. So I think that's kind of a interesting way that they were able to just take action and also kind of study whether this is effective. I think there's a lot of engineering unknowns as far as like how long does the media last? Like, will 6-PPD come off of the soil, or can it like remobilize, and will that become an issue? But I think right now they're just kind of just trying to figure out what works. Finally, they've been looking at wastewater treatment plants because stormwater often gets mixed with sewer systems and ends up in wastewater. So there's kind of mixed results right now. Several studies have found that 6-PPD-quinone was removed very effectively. And then there's another study that found that it was not very effective at removing it. I would kind of imagine that given its affinity to partition to organic matter, that in a wastewater treatment plant that has like an aeration basin and activated sludge, that maybe could be a sink for it, and then that could just be removed. But yeah, this is just one aspect of how we can treat water before it enters the environment, and it's by no means comprehensive of the whole problem. So there's a whole bunch of challenges, just even with sampling and measuring it right now, that's currently being studied and developed. The EPA is about to release a lab standard operating procedure of how to measure 6-PPD-quinone, because in the past couple of years, it's been kind of prohibitively expensive to send it to a really specialized laboratory that can do it. So hopefully it becomes a lot more available to measure in the coming year or two. We also don't know how long it adheres to the organic matter, even though it does for a while. I think this is kind of like just any common filtration technique. Is there a breakthrough point where the contaminant ends up being released after the media reaches its capacity? And then, as I mentioned earlier, the degradation rates are right now theoretical. So currently researchers are trying to validate that because that also affects how it's removed. And if it's really as short as a couple of days, then that could be really convenient for not having to do continual kind of operation and maintenance at a huge scale. And then, yeah, there's a whole bunch of other sources potentially with anywhere there's rubber crumbs, turf fields, landfills. There's tires and marinas that boats bump up against. I think it's a little bit on the lower priority just because car tires wear a lot faster than kind of where they might, where these recycled kind of tires accumulate at the end of their life cycle, but something that I think we should all look into more, or at least consider. Then there's the long-term solutions. I'm only really going to touch on the alternative chemicals because I don't have really much experience with the others, and I think the others are pretty vague at this point. For alternative chemicals, there are some studies right now that are looking just at the obvious other PPDs that have similar behaviors to 6-PPD as far as reacting with ozone. Zhao et al., the link in the first bullet point, has studied this and found that they do form quinones, which are toxic. So it seems unlikely that it'll be as simple as just replacing it with one for the other, kind of similar to how we replaced PFAS in the early 2000s with other kind of similar chemicals, and then they were also found to be toxic. Nair et al. Has also looked at just the toxicity of those other PPDs, but it only looked at rainbow trout, so it's not fully comparable at the moment to coho salmon. And then as far as the tire manufacturing companies go, Flexsys is the main chemical supplier of PPD to the companies in the US Tire Manufacturer Association. So they've agreed to study alternatives. They've partnered with the USDA to do that. And then finally, as of July this year, California's Department of Toxic Substance Control is requiring manufacturers to evaluate alternatives to 6-PPD. And coming in October, they will be requiring reporting on how they are doing that. So I guess lastly, I'll touch on just the kind of the regulation and kind of policy considerations that will have to be accounted for 6-PPD-quinone. Yeah, I'm not a specialist in policy, but I've worked pretty closely with some of the other folks at ITRC who work for the Department of Ecology, and they've provided a lot of really great information that they'll be publishing as far as what is needing to be considered. As far as stormwater regulation goes, there's kind of point source permits, and then there's municipal permits. The point source permits being for industries and construction. A lot of the properties down at the ports in Seattle fall under that category. And then since 6-PPD-quinone is a non-point source contaminant, we're I think leaning towards it being regulated under the MS4 permits, which will fall under phase 1 or phase 2, like the large permits like King County, or the smaller municipalities like some of the smaller cities outside of Seattle. So because of that, that means the permits will basically be requiring controls to the maximum extent practicable. So that's going to mean how do you come up with a plan to design and develop BMPs that can both be cost effective and demonstrate an actual removal of the contaminant before it goes into the waters. So this is something ITRC is currently writing the guidance on with certain people in the policy world on things that will have to be considered. And then in California, they are regulating 6PPD through the Safer Consumer Products Program starting in a few weeks. And that's really just going to, at the moment, that's just going to require the tire manufacturers to submit a notification of intent for one of 4 options. Those options being either they remove the chemical from their products, which can't really happen since that they're critical to the tire structure, either remove their products from the market, or the last 2 options relate to how do you replace 6PPD with a different chemical. So they're probably going to go, they're definitely going that route of studying how do you find other alternatives right now. But even when they do, then you have the number of, like, you have a whole bunch more years of people just currently using their existing tires and going through the existing inventory. So I think it'll still be a problem for it'll be a long-term problem. So yeah, this is just a quick summary of the presentation. It was recognized for decades, but until recently, it was really just discovered that it was a specific compound. Everyone agrees that it needs to be replaced, so they're currently working on that. And then stormwater controls and BMPs are probably going to be the first step to mitigate it before it goes into the water. And there's basically, I think everyone knows now that there's many data gaps and just how all the way from how toxic it is to where partitions in the environment to just how you even treat it. But in the end, I feel like if we can understand its chemistry, we can figure out a way to engineer these controls. Regulation currently isn't. I think the next round of stormwater permits in Washington are coming out in the next year or so, but it sounds like there's too many things to consider right now for it to be actually regulated next year. So I think they're working on figuring out when they can, how do you actually get people to, like, they can't enforce something that is not possible. So right now they're trying to kind of get through all of these unknowns. So with that, that's the end of my presentation. If anyone has any more questions or comments or experiences with it, I'd love to hear it. If there's any more questions, I can also direct to the many documents that I have here. So happy to share.
Thank you very much for the excellent presentation, Mark. Since you mentioned it during your presentation as well, I would encourage people to contact you so that they build a connection with you if they're interested on the matter of 6PPD, regarding the both for the slides and for the links that you have included in there. Does anybody have any questions before I read the Stephen?
Yeah, first of all, I think I saw reference number 30, and not having those references available is not helpful. So if you could make those available, the documents you cited in the presentation, so that people can find them, would be a big help. That'd be very much appreciated. And
yep, I have them all here.
Yeah, I added a comment earlier that everybody who's interested in this read the January 2021 paper by Tian and Ed Kolosky and crew. But there's something very important that you probably don't recognize, is the equipment needed to find this stuff didn't exist 15 years ago. So it's very sophisticated mass spectrometers, and we don't have a lot of them floating around. And Ed Kolosky's group, they worked on this for quite a long time to track down what might be the issue and then test it. So there's an issue of discovery that is very important in all of this. And that's why I think it'd be valuable for you, if you haven't read the paper closely. I see you have a figure from it in your slides, but this is a very, very valuable bit of scientific detective work, and it reflects that. But the other thing that's very important, that was published online at the end of 2020 and in January 8 Science of 2021. And it answered a lot of questions for people at that point. But just think about the speed with which people are responding now that they know what to do. But until that paper was published, people didn't know what to do. And I think that's very important perspective for all of you to have.
Thank you, Stephen. Yes, it's called environmental forensics for a reason.
Yeah, thanks for
Detective
sharing
work.
that. It's really valuable.
Anybody else have a question? Let's see. Sean McCrohan.
Hi, yeah. So my background is in stormwater design and engineering. I'm a stormwater designer, and I work with the State Department of Transportation. And a question that I've seen come up, this is not one that I expect you to have an answer to, but I think it's interesting based on what I've seen in your presentation, is that people are wondering. Obviously, we don't know quite how long the half-life of this is actually in the environment, it seems. And, if it were to stick around, particularly people at the state DOT wonder about, if it sticks around in the soil of some of these open like bioswales and filter strips that we use on state highways, if then they go back and want to maintain that or replace that or do another construction in that area, could that soil be considered some kind of hazardous waste? And how do they handle that and deal with this soil that could have an already documented as toxic chemical in it? And I think if it seems like the half-lives that we know of, at least theoretically, are in the matter of a couple of days, and if it's similar in the environment, that wouldn't be a big concern. But that's a question that I've seen come up. And being someone who doesn't know a whole lot about chemical half-lives and regulation of hazardous waste, I think it's an interesting thing to think about. But
thank you, Sean.
Yeah, I agree. I don't have much to add. I think that has been brought up at some of the other ITRC meetings. So I know that's something they're considering.
I'm working on contaminated sediments in general as well, Mark, and I assume that all of this came to prominence with acute toxicity following storm events, right? Rain events. So it's like acute toxicity, because looking at the KOC, that KOC value of 4, I would assume that it partitions readily to sediments. So that could potentially be a big sink for this compound. But if it doesn't have a long half-life, we would have noticed more chronic toxicity, let's say, from it. But all the mortality cases are from acute toxicity. And I think Brian as well, John Erickson, I'm sorry, has a question similar to that, if you may, John.
Yeah, thanks. I put this in the chat, but I'll ask it live. So I'm just trying to figure out, it's a theoretical question. If all the tires were removed today or replaced with something that's, the perfect rubber, how long would this problem stick around in our water bodies? Obviously, we don't know the answer to that.
In a way,
Probably
yeah.
never happen, but is it theoretical that it could really be solved by the tires?
Well, in a way, we kind of see that over the winter because we do see the coho salmon not experiencing that acute mortality later in the winter after some of the storms have gone through and washed it off of the surfaces. So in a way, yeah, we kind of can say that it would pass through fairly quickly, I think.
So follow-up question would be for BMP designs, would the strategy be something different than we do with like a traditional bioretention? So if there was only like specific times where we know the salmon are in the water and we know the rains are happening, maybe you have something to focus on that time. Maybe that's less expensive. Maybe it's more effective. And then presumably, if you could test the water coming in, you could hit a spot where you're saying, well, in this location, we don't need to do this.
Yeah. Yeah, I think that's a very good point of how do we prioritize or kind of triage the most important areas, whether it's like where a stream might intersect the I-5, for example, or yeah, how do we focus the resources where it's most important?
Thanks.
Stephen?
Just a comment on timing. The typical replacement time for car tires, no matter how much they're worn, is about 5 years, and it's concerned about the safety of the tire. So you have a lot of people who take them longer than that. If you park out on the street, they deteriorate a bit quicker. So the reality would be, if the stuff happened immediately, you were able to make all new tires, it would probably be on the order of 5 to 10 years before you'd start seeing a reduction in the contaminant problem there. So I think you're looking at a time frame that it's at least 10 or 15 years just for handling the situation. Then after that, it'll be some other damn chemical that we haven't thought about that's been put in to try and make something useful. So it's just the challenges. Just think about tetraethyl lead that was put in to make the gasoline supply go further. People knew at the time it was a problem, but they were desperately in need for increasing the gasoline supply, particularly the higher octane. So there's all sorts of things we learn in this, but I think you're looking at a time frame. If people could come up with a proper substitute right now, we're looking at on the order of about 15 years. I won't be around to see it, so that's the story.
Well, thank you very much. Any more questions? We have still 4 more minutes. We did have a good turnout today after all, Mark. Anna. You have a question, Anna? False alarm.
Sorry, no.
Okay. Do have one more question from Tiffany mentioning that the Filtera systems are effective.
Yes, I'm Tiffany. So we heard from a regulator who gave us like preliminary comments saying, have you considered Filtera to handle the 6PPD-quinone for your project? So that was coming from one of the permit reviewers.
I see. That's great to know. Thank you.
Is it true?
I can't speak to Filtera specifically. I just, from Googling it quickly right now, it looks like that would follow some of the same principles of how 6PPD would partition to their filtration systems. So that seems reasonable.
Any other questions before we get the final one from Stephen? Go ahead, Stephen.
Okay, thank you for a very, very informative presentation, and I wish you a very, very successful career. And a special thanks to the 2 wonderful people who've been coordinating these excellent EWRI webinars. They've been professionally highly rewarding, and I thank you for your excellent work in putting them on.
Thank you for always being there for us, Stephen. And you're a treasure that we have, and that we are happy to have as part of our chapter. And with that, if nobody else has any other questions, thank you very much for your time today. Thank you, Mark, for the excellent presentation, as we said. And I hope you have a good rest of the day.
Yeah, thank you all for participating and asking the great questions.
Take care. Thank you. Thank you, everybody.
Thank you. Bye.